Hi everyone and welcome. Today we are going to walk through Handout 5, which introduces one of the most important concepts in all statistics, sampling distribution. Our learning goals for today are straightforward. First, we'll learn how to use sample and replicate function to simulate the process of taking many samples from our data. Second, we'll use the filter function to see how we can sample from the specific subgroup within our population. This handout is designed for practice, and mastering these functions will be essential for completing Lab 5 successfully. Okay, now let's get started with our setup. First, please ensure you have loaded the tidyverse and the open intro packages. We'll be using the NCBurst dataset from the open intro package. The next line of the code is essential. Let's see, set seed 1, 2, 3. So what did this do? It ensures that every time we run our code, the random samples we draw will be identical. This is incredibly important for making our result reproducible, so you can get the exact same output that I do. Okay? Before we build a sampling distribution, let's be clear on the difference between a population mean and a sample mean. The population mean is the true average of our entire dataset. In this case, we can calculate the true average birth rate from all the births in our NCBurst data. We use mean function to calculate. But so you can see it from this block, right? And what if we just took a small random sample? Let's see, a sample of 5 births. So you can see this code in this block. We can use the sample function to do it. If we calculate the mean of those just 5 values, we get a sample mean. If you run this code, you can see that the sample mean is 6.952 and the population mean is 7.101, right? And the population mean is close to the sample mean, probably not exactly the same. And if you run it again without set seed, you will get a different sample mean. This variation is called sampling error. Okay, now let's go to the next part. Anyone's sample mean might be off, but what would happen if we took, say, 1,000 different random samples and calculated the mean for each one? And then we plotted all 1,000 of those sample means. This is exactly what a sampling distribution is. Okay, so you can look at this block to see what is the sampling distribution. To do this efficiently, we can use the replicate function. So when you look at this code block, this is using this line. This is pretty long, right? But let's break this down. We are telling R to replicate the following command 1,000 times. Take a random sample of 10 birth weights and calculate its mean. This gives us a new data set. Sample means 10. Okay? And which contains 1,000 sample means. Okay, now let's visualize this distribution with a histogram. Use ggplot. So I think you are very familiar with it. What you can see here is the sampling distribution for samples of size n equals to 10. Each bar represents how many of our 1,000 samples had a mean in that range. Okay, so what if we are not using the sample size of 10, we are using the sample size of 50? Okay, now let's repeat the exactly same simulation, but this time we just change the sample means from 10 to 50. And we also name it as sample mean 50. Okay, so now let's look at the histogram for n equals to 50. How does this plot compare to the first one for n equals to 10? You should see that distribution is narrow and more tightly clustered around the center. So this is a critical concept in statistics. As your sample size increases, your sample means become more consistent and will be on average much closer to the true population mean. This leads to a more precise estimate. Okay, now finally, R can also makes it easy to ask more specific questions. What if we don't care about the entire population? What if we only want to know about the sampling distribution for mothers who are smokers? We cannot just sample directly. First, we must create a new dataset that only contains the subgroup we want. We use the filter function. Okay. We use the filter function from the tidyverse, selecting only the row of where the habit is smoker. Okay, you can see the code here. And after we have this filter dataset, the process is identical to what we did before. We use the replicate to take 1000 samples of 1000 size 10, but this time we are sampling from the smoker only weight data. The reasoning histogram shows us the sampling distribution of birth weights for the only mothers who smoke. Okay, so now let's summarize what we have learned today. We have covered several key functions: mean, sample, set seed, replicate, filter, and ggplot. So you need to be very familiar with the functions of these tools, okay? The main concept is understanding the sampling distribution is a distribution of statistic taken from many different samples. And you will see this is the foundation for understanding the confidence interval and hypothesis testing. This practice will directly applicable to Lab 5. So if you have any questions, you can email TA or just go to the lab session in person. Okay, so that's it for today.